Hello students, I hope you were doing well. So today we are just going to start the past paper questions related to the alcohols um, in IGCSE and O levels. Okay, so now there's a question number one, and here you can see the reaction scheme is given, and there are five reactions, and according to them, the question has been asked. Now, they are asking that what is the name of the reaction number one? So the reaction number one is conversion of the sugar into the ethanol. Okay, so the conversion of sugar into the ethanol is actually the process of fermentation, right? In which the alcohol is prepared. There are two processes for the preparation of alcohols. That is the ethanol. The first process was by fermentation, that is the biological process, and the second process by the reaction of the ethene with steam water. That is the hydration of ethene. By the hydration of ethene, the alcohols are formed. So, okay. Now the name of the reaction number two. Here you can see the name of the reaction two. So that is the reaction two means ethanol conversion into the carbon dioxide. So that is actually the combustion reaction. Okay, so there are two types of combustion reaction, the complete combustion and incomplete combustion. But now you can see here the carbon dioxide is formed. So whenever the carbon dioxide is formed, so that type of combustion is called the complete combustion. Okay, so that is the complete combustion reaction here. So what will be the equation for that? Now the ethanol have been reacted with C2H5OH. Whenever there is a combustion reaction, it occurs in the presence of oxygen. So it forms the carbon dioxide and water. Because it is complete combustion, so the carbon dioxide will be formed. If it was incomplete combustion, so their product was carbon monoxide. Okay, so how to balance it now? Here the two carbon dioxide, and here you can see the three water and three oxygen here. So you can see here it will be balanced. Um, how many oxygen are there on the reactant side? Seven oxygen. And what about the product side? How many oxygen? Seven oxygen as well. Two to the four, and four plus three, seven oxygen. How many hydrogen are there? There are six hydrogen on the reactant side, while on the product side, six hydrogen as well, and two carbon on the product side and two carbon on the reactant side. So the equation has been balanced here now. Okay, now moving to the another question. So now this is a question that is related to the reaction 3 forms ethanol from the alkene A. Okay, so whenever the ethanol is formed from the alkene, so that is where the addition reaction of the alkene. So keep that in mind. Whenever ethanol is formed, so the type of the alkene that is used to form the ethanol is ethene. Okay. Similar as if the propanol is formed, so the type of the alkene that will be used to prepare it will be propene. Okay. And similar as for the butanol will be prepared from the butene. So now um, the alkene that is used to prepare the ethanol will be ethene. Now the stage the type of the reaction that occurs during the reaction 3. So that the reaction 3 in which alkene is converted into ethanol. So whenever the alkene is converted to ethanol, so that is called addition reaction of the alkene. Okay, in which that is a hydration reaction, in which, like you can say, uh, C2H4 reacted with the water and it forms ethanol C2H5OH, right? So that is, this water is the uh, in the form of the steam, which occurs um, in the presence of phosphoric acid with the temperature 300 degrees Celsius and 60 to 70 atmospheric pressure. So the type of the reaction that will be occurring is the addition reaction. Okay, and state the reagents and the conditions used for the reaction 3. So for this reaction, whenever the ethene is reacted with the water, that is the hydration of ethene, that is actually the addition reaction of ethene, in which the water molecule has been attached, like this. So now this is the ethene. So whenever the water molecule has been added, so that is water molecule OH and H. Now the OH, just a minute. Now the OH and H, right? So the double bond will be break. This double bond will be break, and afterwards this OH will be attached here, and this hydrogen will be attached to this carbon, and it will become, so the hydrogens are same as the ethene, like this, but the addition is of the water, that is OH. Is that clear? So that is why the OH and H has been added into the ethene and it forms the ethanol. Okay. Okay. So the conditions are, the reagent that is used here as a catalyst. So it is phosphoric acid as a reagent. So the reagent that is used here is phosphoric acid as a catalyst, and the conditions that are used for this reaction is 300 degrees Celsius and 60 to 70 atmospheric pressure. So these are the conditions. Okay. Okay, now. So now whenever the alkene is converted, whenever the alkene is converted into the alkane, so that is what, like you can see here, carbon double bond carbon. When it is converted into the alkane, so for this the hydrogen is added here. Okay, so the formula for the alkane is, now the addition of the hydrogen to it. Okay, the double bond will be break here, this double bond will be break down. Whenever there is a addition reaction of alkene, so actually the double bond of the alkene is called unsaturated hydrocarbon. Keep that in mind. When there is a double bond in any organic compound, so that is called unsaturated hydrocarbon. So when it is converted into the carbon single bonds, so it is called saturated hydrocarbon. So for the conversion of unsaturated hydrocarbon into saturated hydrocarbon, so keep that in mind, the double bond will be breakdown. And whenever the double bond is break, so that type of reaction is called addition reaction. So in that addition reaction, in which the alkene, that is unsaturated hydrocarbon, is converted into the alkane that is having the carbon single bond carbon, so the hydrogen is added into it. Okay, so keep that in mind. So like in this way, you can see here, the double bond is break, and the two further hydrogen will be added. Now this, you can see here, these two further hydrogens are added, that comes from the hydrogen H2 molecule. Okay, and it will be forming the alkane. Keep that in mind. Both of the carbon, like you can see here in the alkene, is fulfilling the four bonds. This is, each carbon is fulfilling the four bonds. Okay, so that is the thing. So what will be the reagent and conditions for the reaction 4 in which the alkene is converted to alkane? It is the high temperature, that is the condition, and the reagent that is used is H2 molecule, that is hydrogen molecule. Okay, so the temperature that is the condition, and it is a reagent, right? So what is the general formula for the alkane? So the general formula for the alkane is CnH2n plus 2. This is the general formula for the alkane. Now the question number 2, that the alcohols are the family of the organic molecule which have the same general formula. What is the name given to any family of organic molecule which have the same general formula and similar chemical characteristics, chemical properties? So that is the homologous series. Because homologous series, why we call it homologous series? Because the homologous series, like uh, all the members of the alcohols, like the methanol, propanol, butanol, these all are the part of the homologous series because they belongs to one family, that is the alcohol family. So in the alcohol family, that is including methanol, propanol, butanol, these all have the same chemical properties, having the same general formula, right? So that is called the homologous series because they are belonging to single family, right? And any of the organic molecules that belongs to same family are called the homologous series. So what will be the general formula for the alcohol? So the general formula for the alcohol is CnH2n plus 1 OH. Okay, so this is the general formula. Now the C part, that is the propanol can be made from the propene. Okay, name the reagent and give the condition needed to convert the propene into the propanol. So it is similar as which we have studied in the previous question. That is actually the reagent that has been used here is phosphoric acid as a reagent, and the condition that have been used is 300 degrees Celsius and like 60 to 70 atmospheric pressure. So write the chemical equation for the complete combustion of the propanol. That is C3H7OH is the propanol, and when it has been combust in the presence of oxygen, that is a complete combustion, so it will form the carbon dioxide and the water, right? So it will be balanced now. So that is what this is a complete combustion equation of the propanol, right? Now the third question. Okay, it is asking that the dodecane is an alkane containing the carbon 12. Okay, so what is the general formula for the alkane? It is CnH2n plus 2. If there is n value that is 12, so it will be C12H212 plus 2. So it will be C12, 2 12 are 24, 24 plus 2 26. It will be C12H26. So that is what the dodecane. Okay. So it is saying that the ethanol can be manufactured from the dodecane in two-stage process. In the stage 1, each molecule of the dodecane is converted into 3 molecules of ethene and 1 molecule of another hydrocarbon. So keep that in mind. Here you can see here the dodecane that has been broken down into smaller hydrocarbon. So the process in which the larger hydrocarbon has been broken down into smaller hydrocarbon, so that process is called cracking, right? Write a chemical equation for the reaction which occurs in the stage 1. So that is C12H26. So it is forming what? How many? 3 molecules of ethene. So C2H4 is a formula for the ethene, because the general formula for the ethene for the alkene is CnH2n. If there are, because n is equal to 2, because it is forming ethene, so it will be C2H2 and 2. So it will be forming C2 2 to the 4, that is H4, C2H4. Okay, and plus. Okay, now what happens? Now this C12H26 has been broken down into 3 molecules of the ethene. So 3 molecules of ethene here, and remaining will be what? Now you can see here. How many carbons? C6 and 4 is 12. So C6H12. This 3 is multiplying with C2. So 3 to the 6, C6, and 3 4 the 12, H12. So this C6H12 will be subtracted from this one. So the remaining will be what? It is C6H14, and C6H14 is a alkane, right? So it is a butane actually. Sorry, it is hexane, right? CnH2n plus 2. So this is C6H2 6 plus 2, and it is C6H14, right? So it is actually the alkane, because I am using the general formula for the alkane, right? So I have explained this very much clearly to you guys. Okay, so now it is asking that in the stage 2, the ethene reacts with the steam to produce the ethanol, right? So the same question, same condition, they are asking two conditions. What are two conditions? So these are that is 300 degrees Celsius and 60 to 78 atmospheric pressure. So then the type of the reaction which occurs in the stage 2. So the name of the reaction is um, it is an addition reaction actually, because the ethene reacts with the steam to produce the ethanol. So because the ethene double bond has been broken down, the unsaturated hydrocarbon is converting into the saturated hydrocarbon, that is ethanol. Okay, because the carbon having single bonds. So whenever the carbon double bond has been broken into single bonds, so that type of reaction is called addition reaction. Keep that in mind. Suggest how to test the purity of the ethanol produced. To test the boiling point of the ethanol from known, right? Okay. Now there are some other questions. Ethanol can be manufactured, can also be manufactured by the fermentation of glucose, that is C6H12O6. So what are the conditions needed for the fermentation of glucose? So there are the condition that have been used for the fermentation of glucose, that is in the presence of yeast enzyme. Okay, yeast enzymes, and the second condition is room temperature, that is 37 degrees Celsius. Okay. Okay, what about the complete the chemical equation for the fermentation of glucose? Keep that in mind. In the fermentation of the glucose that has been converted into the ethanol, so it also produce the carbon dioxide gas. And here you can see here one molecule of the glucose. This one molecule of the glucose will produce the two molecule of the ethanol and two molecule of carbon dioxide. Keep that in mind. So now another question. One disadvantage of the fermentation is that the maximum concentration of ethanol produced is about 15%. So it is asking that why the concentration of ethanol produced by fermentation does not exceed the 15%. Because if the concentration of the ethanol has been increased from the 15% to onwards, so it will kill the yeast. Okay, because as the concentration of ethanol is increasing, so the yeast will be killed, the yeast enzyme will not be able to work. So that is why it only produce 15% concentrated ethanol by the fermentation process, because it kills yeast, and yeast enzyme stop working. Give one other disadvantage of manufacturing of ethanol by the fermentation. So the disadvantage is that it takes several weeks, right? Means it is a slow reaction. And what advantage? One of the advantage other than the cost of manufacturing ethanol by fermentation. So the another advantage is that it occurs at the room temperature. So no extra temperature is provided to it. So this reaction occurs at the room temperature, and it use renewable source. Okay. Suggest the process name of the process obtain ethanol from the mixture of ethanol and water. Whenever there is a mixture of ethanol and water, so if you want to obtain the ethanol from that mixture, so that process is called fractional distillation. So that's all about this lecture in which we have discussed the past paper questions. Thank you so much, student.